Hello, my name is Eileen Bresnan. I work for Marine Scotland based at the Marine Laboratory in Aberdeen. I'm here to present some work that was done by the ICES IOC Working Group on Harmful Algal Bloom Dynamics, who generated a description of the diversity and regional distribution of harmful algal events along the Atlantic margin of Europe. I'd like to acknowledge everyone who is involved in this project, particularly those working in statutory monitoring programs whose data contributed to this description. To generate the description, we used over 2,000 records from the IOC ICES Pisces Harmful Algal Event Database, or HADAT. This is now part of the IOC Harmful Algal Information System, which can be accessed at the website here. This is a map of the area included in the study. It involved the Atlantic coasts of Spain, Portugal, France, Great Britain, Ireland, the Faroe Islands, Iceland, the Canary and Salvagin Islands, and the Madeira and Azores archipelagos. The white dots represent areas in the HADAT database that are used to map the incidence of harmful algal events. And this area does experience harmful algal events on an annual basis. The most frequently recorded event are closures of shellfish harvesting areas to protect human health. These are due to high level of algal toxins in shellfish flesh, which pose a risk to humans if consumed. All shellfish product in the EU is tested for the presence of these algal toxins. Algal toxins accumulate in the shellfish after shellfish feed on the algae producing the toxins. When the toxin levels exceed regulatory limits, shellfish harvesting areas are closed until the toxins decline to a safe level where they can reopen again. And there are a variety of toxin syndromes which impact this area within Europe. This is a map showing the incidence of events associated with paralytic shellfish toxins within the area. This time series extends back over 30 years. Routine monitoring began across Europe for the presence of PSTs in response to an event in 1976 when over 170 people became ill after eating shellfish contaminated with paralytic shellfish toxins. And you can see the incidence of closure along the Spanish and Portuguese coast, French, the northwest of France, southwest of England and Ireland, and in Scotland. And there is a regional distribution to the causative organisms, with Gymnodinium, Catenatum, and Alexandrium minutum, the main PST producers in Spain and Portugal, Alexandrium minutum in France, England, and Ireland, and Alexandrium catenella in Scotland. If we look at the temporal time series in 5-year periods between 1999 and 2018, we can see some variability with some periods where there are no closures for paralytic shellfish toxins and some where there are more. And this is related to the abundance of the causative organisms. Routine monitoring for diuretic shellfish toxins began in the 1980s in some areas, in result of a major DST event where several thousand people became ill. And since routine monitoring began, closures of shellfish harvesting areas for the presence of diuretic shellfish toxins are widespread and in many areas are enforced annually. There are two main diuretic shellfish toxin producers in this region, members of the Dinophysis acuminata complex and Dinophysis acuta, with some regional variability, with Dinophysis caudata and sacculus recorded further south, and Dinophysis norvegica recorded further north. And today there are very few incidents of illness associated with diuretic shellfish toxins due to the wide-scale monitoring that's undergone. When we look at the temporal time series of diuretic shellfish toxin events, we can see that closures are widespread most years, although there are some times such as Portugal at the turn of the century and Ireland in 2007, where the number of closures was considerably less. What does vary from year to year is the duration of the closure period. Monitoring for amnesic shellfish toxins began in the 1990s in response to the ASP event in Canada, and closures have been enforced along the Atlantic coastline. The main producer of amnesic shellfish toxin in the area is the diatom Pseudonycha australis, although there are other confirmed domoic acid producers that have been associated with amnesic shellfish toxin events such as Seriata, Multiseries, Pseudodelicatisma, and Plurosecta. And these events all relate to closures of shellfish harvesting areas to protect human health. When we look at the temporal time series of events, we see some areas where the level of closures is relatively consistent, but a marked decline in the number of events in Scotland. And this is due to an amendment to the directive in relation to domoic acid, the amnesic shellfish toxin in king scallops. When monitoring for amnesic shellfish toxins began in Scotland in the late 1990s, there was large-scale enforced closures of the offshore scallop fishing grounds due to high concentrations of the amnesic shellfish toxin domoic acid in the gonad tissue of the king scallop. King scallops are very slow to depurate domoic acid, and as a result, these closures lasted many, many months, sometimes over a year, which had a devastating impact on the industry and on the individuals involved. Now, in the king scallop, domoic acid tends to be concentrated in the gut and the gonad and very little in the adductor muscle. So in an effort to try and resolve the issue, scientists, government and regulators came together to try and come up with a solution. So an amendment to the EU Shellfish Hygiene Directive was generated when the domoic acid content in the gonad tissue exceeded 20 micrograms per gram. The scallop could be shucked, that is, the gonad and the gut and viscera removed, and the adductor muscle could be sewed if the domoic acid in the adductor muscle was less than 4 micrograms per gram. And this is usually the case as the adductor muscle contains very little domoic acid. So this move to shucking along with end product testing meant that the scallop fishermen had a product that they could place on the market. And when this amendment to the directive was implemented, it eliminated the requirement to close the offshore scallop fishing areas. So from 2005, this part of the time series was no longer collected because there was no closures of scallop fishing areas, and this manifests itself in the HADAP data as a reduction in the number of events. The majority of events associated with azosphoracids in the area are recorded along the west and south of west coast of Ireland. There are very few events in Scotland, England, or Spain. The main azosporacid producing species in the area is Azidynium spinosum, although Azidynium vaporum and Amphidoma languida have also been recorded. Sikatera poisoning is a poisoning that occurs when people eat fish whose flesh has been contaminated with Siga toxins. This was thought to be a syndrome that was more restricted to tropical areas, but in 2004, an endemic case of Sikatera poisoning was recorded in the Canary Islands. It was recorded again in 2008 in the Canary Islands, as well as the neighboring Selvagium Islands. And since 2008, in the Canary Islands, it's been recorded annually, with the exception of 2014. The Sikatera toxins are produced by benthic dinoflagellates, and in this instance by members of the dinoflagellate genus Gambiodiscus. And the Gambiodiscus population in the Canary Islands is relatively diverse. To date, there have been 6 species identified, all of whom produce Sikatera toxins, although in laboratory culture, Gambiodiscus eccentricus and Gambiodiscus australis produce the most. And this diverse population suggests that this population is endemic to the area and hasn't been introduced. The outbreak of Sikatera, the advent of Sikatera poisoning in the Canary Islands is seen as a potential climate change impact with warming winter water temperatures facilitating the expansion of the Gambiodiscus growing season over winter. Since the outbreak, there's been a lot of management actions and investigations in how to mitigate the risk from Sikatera poisoning in the area. There's been epidemiological protocols established and strict definitions to define cases of Sikatera poisoning so they can be better identified. And monitoring programs have been put in place where fish over a certain weight are monitored for the presence of Sikatera in their flesh in order to prevent it entering the food chain. And since 2015, it's been considered a notifiable disease in the Canary Islands. This area has also suffered mortality events of aquaculture and natural fish, as well as benthic animals and birds and dogs. And these events do not have such a regulated reporting system for shellfish as the shellfish harvesting area closures. And while the major events are likely to be included in the database, some of the smaller, more local scale ones may be underreported. The mortality events of aquaculture fish are particularly important because they can have a very severe economic impact when all of the high value product is killed by the impacts of a variety of harmful algal species. Within the harmful algal event database, there are two main causative organisms that have caused mortalities of aquaculture and natural fish, and some of these also affect benthic animals. These are the dinoflagellate Carania mikimotoi and the rhapidophyte heterosigma aquashiwo. These events are sporadic, they don't occur every year, and with the exception of the Faroe Islands and Iceland, there haven't been events associated with heterosigma aquashiwo for a number of years. There are other species that have caused mortality, such as Primnesium parvum, Pseudochatonella verruculosa, Flagellate X, which is suspected to be either a species of Pseudochatonella or Chatonella, and Alexandrium catanella. There's also been mortalities of birds and dogs along the east coast of England, and these have been associated with the PSP producer Alexandrium catanella. But the number of events of mortalities of fish and benthic animals and birds and dogs are not recorded as frequently as closures of shellfish harvesting areas in this region of Europe. Countries in this region are also studying emerging toxins to be prepared in case they become problems in the future. And while they have recorded the presence of pinotoxins and spiralides, they are not causing problems yet. There's also been studies done looking at the distribution of benthic HAB species, and there's some cause for concern as to about the Osteriopsis siamensis in the Bay of Biscay and its potential to produce aerosolized toxins. In order to try and mitigate the risk of all these harmful events on the industries they impact, countries are also working on developing early warning systems so that they can give the aquaculture industry in particular as much notice as possible of the potential for HAB impacts on their industries. And they're using a number of methods to do this, such as making data available and doing risk assessments based on the data that's being collected, as well as embracing new technologies such as satellite imagery and more automated monitoring methods to improve their risk assessments. And this is something that's going to develop in the future. So in summary, the majority of HAB events in the Atlantic margin of Europe are associated with shellfish toxins. Events associated with DSTs are widespread and enforced most years. Events associated with paralytic shellfish toxins are more temporally and regionally variable. Management actions have reduced the impacts from ASTs in some areas, but these events continue to be recorded. And the majority of events associated with azosphoracids are recorded in Ireland. Sikatera poisoning has emerged as a problem in the Canary Islands since 2004, and also with reports coming from the Selvagen Islands and the Madeira Archipelago. The majority of mortality events to date have been associated with blooms of Corania mikimotoi and Heterosigma akashiwo, and these events may be underreported from a more local scale. And countries are currently working on early warning systems to try and manage HAB risk and reduce their negative impact. So if you want more information, there are 2 papers that contain some of these events. The paper from the ICES IOC Working Group on Harmful Algal Bloom Dynamics, and also the synthesis paper from the Global HAB Status Report, which places this data in a more global context. Thank you.